Okay, so the directions for dividing a polynomial by monomial will say something like this. So I'm going to write this as directions. So you may see it say perform the indicated, oh, I'm sorry, perform the division. All right, perform the division. It could say that. It could also say, it could also say, find the quotient. Find the quotient. And remember, quotient means the same thing as division. So find the quotient. Okay, so here's an example. Here's an example of a polynomial being divided by a monomial. So here's what the numerator is. So the numerator, let's say, is 12a cubed plus 8a squared. 12a cubed plus 8a squared. So that's the numerator. And the denominator, let's say, is 4a. All right, so that's our problem. So notice I have a polynomial with two terms, 1, 2, divided by a monomial, one term. That's a monomial. The best way, the way you want to do this, whenever you are dividing a polynomial by a monomial, the easiest way is this idea. So remember in the past, many years ago, you did something like this, let's say. So you had 8 plus 4 divided by 2. You know that you can rewrite this as 8 divided by 2 plus 4 divided by 2, right? 8 divided by 2 is 4, 4 divided by 2 is 6, 2, and you get 6. You could have also said 8 plus 2 is 12, and 12 divided by 2 is also 6. The way you want to do this is this way here. So you take each term in the numerator divided by the monomial, by that one term. So I'm going to take each term here, I'm going to divide it by this monomial using this idea. So this becomes 12a cubed divided by 4a plus 8a squared divided by 4a. Okay? And then what I want you to think about is this. So you got to simplify now. You have to simplify each of these fractions. So notice I wrote this one fraction where I had a polynomial divided by a monomial into two fractions. A monomial divided by a monomial divided by a monomial. And then you can think of this in several ways, and you have to have these different points of view. Having different points of view when you look at these problems will help you in many situations. So for example, I know that 12 divided by 4, so if you want to, you can think, and let me go ahead and rewrite this over so I can write on it. So I'm just rewriting this over. Um, so, so you know that 12 divided by 4 is 3, right? And you know that a cubed divided by a, so a cubed divided by a, I'm going to go ahead and put that here, a cubed divided by a, think of this in different points of view. So a cubed means a times a times a, and then a is just a, and then reduce. These a's divide out, right? And you get 1 times a, which is a squared. So a cubed divided by a is just a squared. So this right here becomes 3a squared. So I simplified this fraction as 3a squared plus, and then do the same thing here. If you need to, cover up some stuff or circle some stuff. Here, a divided by 4, that's a nice thing to look at because that's just 2. And then a squared divided by a, think of this point of view as well, just like we did here. So a squared divided by a means a times a divided by a, and then reduce. So 1 times a is a, so a squared divided by a is just a. And there's your answer. Now don't say that's 5, because remember, those are not like terms, right? So these are not like terms because this term has exponent 2, and that's called the degree of that term. The degree, I'm using the word, let me go ahead and write it on here. I'm using the word degree of term. So the degree of this term is 2, the largest exponent that you see there, because there's only one variable. And the degree of this term here is 1. So the exponents are different, so you cannot combine them, so there's your answer. I want you to look at this in another point of view. Okay, so listen carefully. I'm going to go back here. A cubed divided by A. Remember in a previous course you learned about the property I'm about to remind you about. When you divide like bases, you subtract exponents. So there was a property that you learned in a previous course that looks something like this. Let's say we had x to the a power divided by x to the b power. So the property said when you divide like bases, you subtract exponents. So x to the a power divided by x to the b power was x to the a minus b. And so if I look at this, these bases are the same, so therefore I can use this property. And so I can rewrite this as a to the third minus, and since there's no exponent there, that's understood to be 1. And 3 minus 1 is 2, so this is a squared. And this is what we got here. So you think about these in different points of view. It helps. Same thing here. You see that a squared divided by a? Same thing. A squared divided by a. I'm going to use this property. So I'm dividing like bases. I'm going to subtract exponents. 2 minus 1. It's always the exponent of the numerator first, and then subtract the exponent of the denominator. 2 minus 1 is 1, so I just get a. And that's what you saw here. All right. Okay, so that was example 1. All right. Now, the more you do, the quicker you can get through this. Now, if it says show work, I expect something like this. Okay, so you go from here to here, and then the answer if you want to. From here to here, and the answer. If it doesn't say anything about showing work, then you can go from here to the answer. You see, it's easy to do that. It's easy to go from here to the answer. Most of you can look at that and indicate what the answer is. Okay, let's go to number 2. Number 2, and I'm going to need another sheet of paper. Okay, number 2, let's say we had this. For number 2, we had 18 r to the 5th, that's an r, 18 r to the 5th, plus 36 r to the 4th, plus 27 r cubed, and I'll put that in parentheses, and that's being divided by 9r. Now you may say, well, that looks totally different than something like we had here. Well, it's the same thing. It's just that this is written horizontally. Okay? So what you want to do is take this and write it like this. That's what you want to do. So let's do that. So that's going to equal, this is going to be your numerator. So that's going to be equal 18r to the 5th plus 36r to the 4th plus 27r cubed, all divided by 9r. Now notice I have a polynomial divided by a monomial. So since this is a monomial, I can rewrite this as each term, and there are 3, 1, 2, 3, divided by this monomial, the denominator. The monomial, though, it's a monomial. So it's 18r to the 5th divided by 9r, plus 36r to the 4th divided by 9r, plus 27r cubed divided by 9r. And then we just use all of these ideas that we talked about, the different points of view. So if you look at this one, the first fraction, 18 divided by 9 is 2. R to the 5th divided by r, again, you could think of this mentally right away. You know what this is. R to the 5th, you have five factors of r divided by 1. You all know that you're going to have 4 left, right? But let's think about this. Let's look at this in these point of views that we talked about. R to the 5th divided by r. I can use a property that says divide like bases, subtract exponents. So that's r to the 5th minus 1, which is r to the 4th, right? I could also think of this as r times itself 5 times, right? 1, 2, 3, 4, 5 divided by 1 factor of r, and then reduce. R times r times r times r times 1 is r to the 4th. Okay, so same thing. So this is 2r to the 4th. So this fraction becomes this, plus, and do the same thing with the next one. 36 divided by 9 is 4. R to the fourth divided by R. I have 4 factors of R in the numerator, 1 factor of R in the denominator. I have 3 factors in the numerator. Okay? And then here, 27 divided by 9 is 3. R cubed divided by R. Again, go through this process if you have to. R cubed divided by R. That's R times R times R divided by R. Reduce, that's R squared divided by 1, right? Which is just R squared. So that's 3R squared. Now notice that those are all different terms. This term has degree 4. Remember, I used the word degree again, degree. This term has degree 3, and this term has degree 2. Those are all different exponents, so those are not like terms. So that's your answer. All right, number 3, we have 2n cubed plus 20n squared minus n divided by 10n squared. That's an n squared right here. Okay, again, go through the process. So you have a polynomial divided by a monomial, so write them as separate fractions. So that's going to equal 2n cubed divided by 10n squared plus 20n squared divided by 10n squared minus n divided by 10n squared. All right, so first thing you're going to do. This one, now you got to remember, you got to think about what you have here. So let's go off to the side and look at this part here. So I have 2n cubed divided by 10n squared. All right, so I'm going to circle this right here. All right, now be careful. This is not 10 divided by 2, so don't say the answer is 5. It's not 5. It's 2 divided by 10. Okay? So the way you want to think about this is this. So if you want to, let's do it like this. I'm sorry, 10 right here. So reduce first. 2 into 2 is 1. 2 into 10 is 5, right? So that I have circled is 1/5. Now let's look at this one right here. Let's look at this. So I have n cubed, we'll put that here, n cubed divided by n squared. So remember, that means n times n times n divided by n times n. N cubed divided by n squared, and then reduce, just like this. So 1 times 1 times n is n, 1 times 1 is 1. So this, if you want to write it next to this, that will be times n divided by 1. Now, this right here becomes 1 times n is n. 5 times 1 is 5. That goes here. So that's n divided by 5. So sometimes you will need to take what you see, go off to the side, and think about it in those different points of view. Okay? So that's what this is. So make sure you see that 2/5 is 1/5. But don't put the 1 there, because 1 times n means the same thing as n. Okay? So you write as 1 fraction. You simplify this as 1 fraction. Now let's look at this one. So if you need to go off to the side and work it out, then do that. So I'm going to rewrite this right here. So that's 20n squared divided by 10n squared. Okay? So let's break it down like this. So you know that this I can write as 20 divided by 10 times n squared divided by n squared. Okay? Well, you know that 20 divided by 10 is 2, right? So that's easy, because 10 into 10 is 1, 10 into 20 is 2. And you know that n squared divided by n squared, so anything divided by itself, those all divide out, that's just 1. So that's 2 times 1. And then 2 times 1 is 2. So this right here is 2 divided by 1 for right now. Okay, so just write it as 2 divided by 1. Okay, and then minus. Now let's go over here. So n divided by 10n squared. So let's do that work right here. So that's n divided by 10n squared. Okay, now be careful with this. Some students kind of mess this one up right here. So you see how I had a number right here and a number right here, and you may say, well, I don't see a number here. Well, you don't see it, but remember, that's understood to be a 1. So it may help you if you put a 1 there. So now you can say I can write this as 1 divided by 10 times n divided by n squared, and then simplify. Well, I cannot simplify 1 divided by 10, so I'm going to leave it as 1 divided by 10. But I can simplify n divided by n squared, because I know, I'm going to put that here, I know that n divided by n squared means n divided by n times n. So remember, n squared means n times n. And then reduce, the n's divide out, and notice what happens. You have 1 divided by 1 times n is n. So this right here is 1 divided by n, so I'm going to put that here. Now write this back as one fraction. 1 times 1 is 1, 10 times n is 10n. So that fraction goes here. So this is this. See, this right here is this, and then we did all this work right here and we got this. So that's 1 divided by 10n. Now what I want you to do, we all know that 2 divided by 1 is 2, so we prefer that you write the answer like this: n divided by 5 plus 2 minus 1 divided by 10n. So whenever you have a 1 in the denominator, just rewrite it without the 1. All right. Now, so that the way we did this right here was we saw that these factors are the same. So when they divide, when we reduce them, we get factors of 1. So that's why you see that 1 here. And the way we reduce this was this way. So we wrote out what the factors are and then we reduce. But I want to go back and I want to remind you, and I don't think it's on this page, it's on the other page. I want to remind you about this property right here. So let's talk about that in here. Okay, so listen carefully. So it's important that you remember these properties. Okay, so you see this right here where I had n squared divided by n squared? I had n squared divided by n squared. You know that when you divide like bases, you subtract exponents. So that becomes n to the 2 minus 2. 2 minus 2. Well, 2 minus 2 is 0. So that's n to the 0 power. Now, some of you probably forgot what n to the 0 power means. Well, n to the 0, any variable, as long as it's not equal to 0, raised to a 0 power is 1. So this right here, n squared divided by n squared, using that property when you divide like bases, subtract exponents, 2 minus 2 is 0. Well, n to the 0 is 1, and that's what you see here. So see right here, where we put it, right here. So n squared divided by n squared is 1. That's this right here. All right, so different points of view. It helps to know these different ways of doing this. It does help you. Now let's look at this one here. I want to show you something about this one. All right, so you may say, well, what about this one that we just did? Because it's easy to see how we got this to this 1 over n by just reducing. But let's look at it this way. What if I had n divided by n squared and I wanted to use this property right here? Well, remember, this is 1 right here. So when I divide like bases, I subtract exponents. And this is where some of you are going to forget about something you've learned a long time ago. 1 minus 2, right? Well, 1 minus 2 is not 1. 1 minus 2 is a negative 1. Okay. Now, if you use this point of view and you get a negative 1, don't write this as n to the negative 1 as your answer. Because I'm going to say this. Always make sure your answers have positive exponents. Always make sure your answers have positive exponents. So this is negative. All right, so that's going to bring us to another property you learned in a previous course. And here's that property. Whenever you have an expression raised to a negative power, and that's what we have here, then you can rewrite this as 1 divided by a to the positive power. So basically, you rewrite this to where you put this in the denominator, and notice that the sign of the exponent changed. Negative p became positive p. All right. Okay, so if you use that property here and you get a negative exponent, you got to make sure you rewrite it as a positive exponent, because if you leave it, you're not going to get all your points. All right, so that's why for some students, it's very helpful if you know this point of view and if you know this point of view as well, knowing these different properties. Okay, let's look at number 4. Number 4, let's suppose in number 4 we had this problem. Number 4. All right, number 4. Um, Let me go ahead. It looks like someone's snoring. Is make sure you're muted because I'm hearing some background noise. All right, I don't see any. Okay, let me go ahead. There's one person not muted, so I'm going to go ahead and mute that person. Okay. All right, number 4. Okay, number 4. Let's suppose we had this in number 4. We have m to the 4th n squared plus mn cubed divided by mn. And let's leave it like that for right now. Okay, so again, I have a polynomial divided by a monomial. So I'm going to write this as two separate fractions, one term, two terms. So I get m to the 4th n squared divided by mn plus mn cubed divided by mn. Okay, now the way you want to think about this is this way. So I'm going to go ahead and just take this right here and put it here, just so we can talk about it. M to the 4th n squared divided by mn. It helps if you think about this by circling the like variables. I'm circling the m's and then I'm circling the n's. Okay? And then if you need to, rewrite it. Rewrite this as m to the 4th divided by m times n squared divided by n. Rewrite it like that because that's what this can be written as. And then we use our properties. I have 4 factors of m, 1 factor of m. So think about that. So if I divide like basis, I subtract exponents, that's m to the 3rd power, right? And that's a positive exponent. That's what we wanted. So this right here is just m to the 3rd power. Do the same thing with this. N squared divided by n. Divide like basis, subtract exponents, that's m to the 2 minus 1, which is n to the 1st, which is just n. So this is this. So that's going to go here. So that is equal to m cubed n. Okay, so I simplified this to this. Plus, do the same thing here if you have to. M n cubed divided by mn. So if you need to, just like we did in the previous one, circle the like variables and then rewrite it. If you have to rewrite it, you rewrite it. So that's m divided by m times n cubed divided by n. Well, m divided by m, that's 1, right? These divide out. Those are like factors. So that's just 1 times n divided by n cubed, rather, divided by n. Remember a point of view would be to think about it as n times n times n divided by n and then reduce. So you're just left with n squared. That's what this is. And then 1 times n squared is just n squared. So that goes here. And there's your answer. You can't combine those. Make sure you understand that those are not like terms because this has variable n in it and this has a variable m in it. So those are not like terms. Also, this has 2 factors of n. This only has 1. All right, so that's your answer. You're done. That's nothing else you can do. All right, so that's number 4. Okay, number 5. We have 8 x to the 8th minus 12x to the 6th, and we'll put that in parentheses, being divided by a negative 4x to the 8th. All right, so again, it's written horizontally, so you're going to write it like this. So I'm going to rewrite this as 8x to the 8th minus 12x to the 6th divided by a negative 4x to the 8th. That's how I'm going to write this. And now notice I have a polynomial divided by a monomial. So I'm going to rewrite this as 2 separate fractions. 8x to the 8th divided by negative 4x to the 8th minus 12 x to the 6th divided by negative 4x to the 8th. Okay? And then this one's I'm going to go ahead and rewrite the first one. So we have 8x to the 8th divided by negative 4x to the 8th. So if you have to, then circle this. 8 divided by negative 4 is a negative 2. X to the 8th, those are the same factor, so those divide out, right? You can also think about it this way. X to the 8th divided by x to the 8th. Divide like basis, subtract exponents. That's x to the 8th minus 8. 8 minus 8 is 0. And you know that 8x to the 0 power, anything raised to 0 power except 0, is 1. So that's negative 2 times 1, which is negative 2. This is just negative 2. Okay? Now let's talk about this. Now here's what I want you to think about this. Even though you think of this as subtraction, also think of this as adding the opposite. So that's really a negative divided by negative. A negative divided by a negative is a positive. So that becomes a plus symbol. All right, now I'm going to rewrite this as, I'm going to put that here, 12 divided by 4 times x to the 6 divided by x to the 8. So I'm going to rewrite this, okay? All right, now this part is easy. 12 divided by 4 is 3. Okay, now listen to this. This is x to the 6 divided by x to the 8. So if I use the idea of dividing like basis, subtract exponents, I want you to see what happens. This is x to the 6, subtract 8, right? Well, 6 subtract 8 is not 2. 6 subtract 8 is a negative 2, so that's 3x to the negative 2. But remember, you need the exponent to be positive. Well, you know that, and let me go ahead and cover this up. You know that this means this, 1 divided by x squared. And so that's times 3. And as one fraction, that's, remember 3 is 3 over 1. So 3 times 1 is 3. 1 times x squared is x squared. So this right here is 3 divided by x squared. And there's your answer. That's the answer. Now, I want to look at this in another point of view. This right here, the x to the 6 divided by x to the 8. Now, x to the 6, remember, x to the 6 means 6 factors of x. X to the 8 means 8 factors of x. So it's a lot of factors of x that you'll be writing. But let's look at this. I have x times x times x 6 times. Okay? 1, 2, 3, 4, 5, 6. In the denominator, I have x times itself 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And then reduce. So I'm reducing like factors. Okay? I'm just reducing. And then there's nothing else I can reduce. So all these are products of 1s. So the numerator is 1. All these right here is products of 1. So 1 times x is x squared. Well, isn't this right here? Isn't this right here? This right here? We remember x to the negative 2 is 1 over x squared. All right, so different points of view. It helps to know the different points of view. All right, and that's the answer to that one. So it's negative 2 plus 3 divided by x squared. All right, so that's number 5. Okay, let's look at number 6. So we have about 2 more, and then we're going to look at long division. Okay, number 6. So number 6, we have negative 42 x to the 6th power plus 42 x to the 4th power minus 49 x to the 2nd power divided by negative 7 x to the 4th. Okay? All right, so a polynomial divided by a monomial. So I'm going to rewrite this as each term divided by the monomial. So negative 42 x to the 6th divided by negative 7 x to the 4th plus 42 x to the 4th divided by negative 7 x to the 4th, minus 49 x squared divided by negative 7 x to the 4th. Okay? Now let's go ahead and simplify each one. So this right here, this right here, negative 42 divided by negative 7 is a positive 6. X to the 6th divided by x to the 4th, that's just x squared. So that is this. So that's easy to see. Over here, a positive 42 divided by negative 7, this time is a negative 6, right? Remember, these are like factors. So these divide out, right? And so that's negative 6 times 1. This is just 1, right? Okay, now we're going to come back and we're going to fix this, but I just want you to remember that this is negative 6 times 1. Now, this is where you need to be careful right here. So I'm going to go off to the side and rewrite this. So, well, first of all, notice that a negative divided by negative is a positive, so that's going to be a plus right here. Now, let's talk about 49x squared divided by 7x to the 4th. Okay, so let's move this to the side. This one's easy, 49 divided by 7, 7. So I had no issue there. Now remember this though, be careful. See, that's x squared divided by x to the 4th. Think about this in different points of view. Divide like basis, subtract exponents. So it'll be x to the 2 minus 4. 2 minus 4 is a negative 2. I don't want negative exponents, so I got to rewrite this. So that's 1 over x squared. So this becomes 7 times 1 over x squared. And 7, remember 7 over 1, so 7 times 1 is 7. 1 times x squared is x squared. So this is 7 divided by x squared. Okay? Another point of view is this. X squared divided by x to the 4th. Remember, x squared means x times x. X to the 4th means x times itself, 4 times, right? And then reduce. So I get 1 times 1 is 1. 1 times x times x is x squared. This is the same thing as this. All right, and so we get that. Now, don't say that's the answer, because I need for you to remember that 6 times 1 is 6. So this becomes, so the answer you're going to write is going to be this. 6x squared minus 6 plus 7 divided by x squared. All right, so that was number 6. All right, let's look at number 7. Let me do number 7 on another page. So here's number 7. Okay, so number 7, you have 36 x to the 7th y squared minus 24 x to the 8th y cubed divided by 4 x squared y. So I have a polynomial divided by a monomial. So remember, the way you're going to divide is to rewrite this. Rewrite this into two, since I have two terms up here, rewrite this into two fractions. So the first term divided by the denominator, and then the second term divided by the denominator. And then you reduce. Okay, just like we've been doing. So remember, you're going to circle the like parts. So I'm circling the x's, circling the y's, and now let's talk about that. 36 divided by 4 is 9, right? This is 7. X to the 7th, think about this, x to the 7 divided by x squared. You have 7 factors of x in the numerator, 2 factors of x in the denominator. You're going to have how many left? 5. So 5 factors of x. 2 factors of y, 1 factor of y, you have 1. So this is this. Minus, do the same thing if you have to. 24 divided by 4 is 6. X to the 8th divided by x squared, you have 8 factors of x in the numerator. You have 2 in the denominator. When you reduce common factors, you're left with 6. 8 minus 2 is 6. Over here, y cubed divided by 1, that's a 1 here. So that's 2, right? Y cubed divided by y is y squared. And there's your answer. Those are not like terms, because first of all, if you notice the x's, they have different different exponents. And the same thing for the y's. So that's your answer. You're done. You are done. All right, one more, number 8. We have 35 y to the 4th z plus 8 y to the 6th z to the 7th minus 35 y to the 5th z to the 4th, all divided by 5 y to the 5th z to the 6th. Okay. So I have a polynomial divided by a monomial. The way to divide, the way to find this quotient is to take each term, divide by the monomial. So this is going to be 35 y to the fourth z divided by 5 y to the fifth z to the sixth, that's a 6, plus 8 y to the sixth z to the seventh divided by 5 y to the fifth z to the sixth minus 35 y to the fifth z to the fourth divided by 5 y to the fifth z to the sixth. Okay, so that's the first thing I would do. All right, then let's talk about each one, and I'm going to talk about each one separately. Okay, so I'm going to take this, I'm going to rewrite it here and talk about it. So let's look at this one here. So that's 35 y to the fourth z divided by 5 y to the fifth z to the sixth. So you see I'm kind of aligning my like variables. Okay, now let's talk about this. I'm going to move this away and look at this right here. 35 divided by 5 you know is 7 times. All right, now let's rewrite this right here. So what's going to get some students into trouble is they're going to say, well, I have 4 factors of y, 5 factors of y, so I'm left with 1 factor y. They make the mistake by saying this. They make the mistake by saying this is going to be 7y. It's not. It is not 7y. Okay, so you got to be careful. So look. Think about your point of view, do your different points of view. So I have y times y times y times y. That's the numerator. The denominator I have 5. Y times itself 5 times, right? And then reduce. These divide out, these divide out, these divide out, these divide out. 1 times itself 4 times is 1. The numerator is 1. The denominator is 1 times y is y. So this is 7 times 1 divided by y, not y. 1 divided by y. And the other point of view, remember, is this. Y to the fourth divided by y to the fifth. Divide like basis, subtract exponents. That's y to the 4 minus 5. 4 minus 5 is a negative 1. You don't want negative exponents. So this becomes 1 divided by y. Y to negative 1 is 1 divided by y. And that's what you see here. Same thing here. Don't say I have 1 factor of z in the numerator, 1 factor of z in the denominator. I'm sorry, 6 factors of z in the denominator and say that's z to the fifth. It is not z to the fifth. Because if you think about this, like we did with this one, you have 1 in the numerator and 6 in the denominator. Okay? And then if you reduce, you get a 1 in the numerator, factor 1. In the denominator, you have 1, 2, 3, 4, 5. 5 factors of z, so that's z to the fifth. So that's what goes here, times 1 over z to the fifth. But you got to write this as one fraction, though. So in other words, put something in the numerator. So remember that's 7 divided by 1. So 7 times 1 times 1 is 7. So 7 goes in the numerator. 1 times y times z to the fifth is y z to the fifth. So that goes here now. So this right here, when I reduce, is 7 divided by y z to the fifth. Then you go to the other one. You do the next one now. So let's do the next one. So the next one I'm going to rewrite. I'm going to rewrite this here. So the next one's this. 8 y to the sixth z to the seventh divided by 5 y to the fifth z to the sixth. Okay? All right, then I'm going to reduce. So we're going to circle all the like parts, and let me go ahead and mute that person again. Okay. All right, so then I get 8 to the fifth. I cannot reduce, right? So that's 8 to the fifth. I'm sorry, 8 divided by 5, excuse me. 8 divided by 5 I cannot reduce. I can reduce this because I have 6 factors of y in the numerator, 6 factors of y in the denominator. So think about your point of view. One way is to look at this in terms of dividing like bases. So when you divide like bases, you subtract exponents. 6 minus 5 is 1, right? So that's positive. So that's just y right here. Okay? Over here, I have z to the 7 divided by z to the 6. Divide like basis, subtract exponents. Z to the 7 minus 6, again, that's 1. So that's just z. But don't leave the answer like this because you want to write it as one fraction. So remember, that's y divided by 1, z divided by 1. Now look, 8 times y times z is 8yz. 5 times 1 is 5. So that is going to go here now. So let me go ahead and take this away. So that right here is this. So that's going to be 8yz divided by 5. And then finally, you do it with this one as well. Okay, so let's do that. So I'm going to rewrite this. So we subtract. So I'm going to rewrite this part here. I'm going to put that here. All right. So again, it helps if you write this stuff out. Some of the ones we've done you can do mentally. Some of them requires you think about it so you don't mess up. So you don't do something like this right here. See, that is not the same thing as this. Those are different. Okay, so I'm going to go ahead and rewrite this term. So that's 35y to the 5th, z to the 4th, divided by 5y to the 5th, z to the 6th. All right, so I'm going to circle these, circle these, circle these. Okay, 35 divided by 5, that's easy. That's 7. Times y to the 5th divided by itself, that's easy too, right? That's 1. We also know if you want to use this idea, I'm going to point it out to you again. Divide like basis, subtract exponents, right? So that's y to the 5 minus 5. 5 minus 5 is 0. And y to the 0 is 1. Anything raised to the 0 power is 1. So that's what you see here. Over here, be careful. Don't say that z squared because it's not z squared. Think about that. Z to the 4th divided by z to the 6th. Divide like basis, subtract exponents. That's z to the 4 minus 6. 4 minus 6 is a negative 2. We don't want negative exponents, so make it positive. So you're going to rewrite this as 1 divided by z squared. So that's 1 divided by z squared. The other way you can think about this is this. I have 4 factors of z in the numerator. I have 6 factors of z in the denominator. And then reduce. These divide out, these divide out, these divide out, and these divide out. And notice all you have are products of 1, factors of 1 in the numerator. So that's a 1 here. And then z times z, which is z squared. So that's the same thing as this. But again, you want to rewrite this as one fraction. So for some students have trouble when it looks like this. They want to think that you're going to multiply 7 times the numerator and 7 times the denominator. That's not true because that's 7 divided by 1 and that's 1 divided by 1. So 7 times 1 times 1 is 7. 1 times z squared is z squared. That's what you need to write. That needs to be written here. So that's going to be minus 7 divided by z squared. Okay? So this is here. Notice that with that one, and number 8 was the one that took the longest because there was a lot of different things in here. Notice though that you may not have been able to do this mentally. You needed to have done this by writing it out and thinking about these ideas. Okay, so that is part of what you're going to study on Wednesday. So this is where we looked at a polynomial and we divided it by a monomial.